Okay, so 6.5 notes is working with those factors. So we've been working real hard on factoring quadratics, and now kind of the next step is, well, what do we do with them? So in order to kind of address that question is we got to talk about what we can do with factors of quadratics in terms of the fact that it's a product, right? So we're going to start out with a kind of this scenario here. Let's just take two numbers, multiply them together, and we find out the answer is 12. Well, what are my options? Well, it could be 1 times 12. That gets us 12. That's not the only option, though, right? It could be 2 times 6. That also gets us 12. It could be 3 times 4. That also gets us 12. In fact, it doesn't even have to be two integers. It could be like 1/2 times 24, right? Half of 24 is, hey, 12. So we have just infinitely many possibilities here. We could have -3 times -4, and that could go on. But something really unique happens when we multiply two things together and it equals 0. We still have infinitely many possibilities. I mean, like, 1 times 0 is 0. 7 times 0 is 0. 0 times -3 is 0. 0 times 1/2 is 0. I mean, we could even go irrational numbers, right? The square root of 3 times 0, 0. So the one thing that we get is that either A is going to be the 0, A is going to equal 0, or B is going to equal 0. And that is necessary in order to get a product of 0. So let's do some fill in the blank here. What times 1.08 is 0? Well, this has got to be, if 1.08 is not 0, then A's got to be 0. 5 times what equals 0? Well, this is the 0 now. Now we have a little extra step. The only way that can be 0 is if this is 4. Well, what about here? Well, if this is the 0, then x is a positive 2. If this is the 0, then x is a -3. So we have two answers here in this situation. And if you notice, this is a factored quadratic. And that's where we're heading with this, is what happens when we have a quadratic and we factor it, and we want to know when it's 0. Okay? So we're going to do that with that quadratic factor, and we're going to actually do that because we need a little more space to investigate. We're going to do that down here. So we're going to do that down there. Now, one thing to note is that if we go with the x equals 2 option, then this is 0 and this is 5. But 0 times 5 is still 0. If we go with the x equals -3 option, then we have -3 plus -2, which is -5, times 0, which is 0. So we have two locations on the number line where we have 0. We have a number that will give us a 0 product. And that's going to become important. Actually, I think it's going to become so important, I'm actually going to mention it here. So if we would graph these solutions on a number line, we would have -3. Oops, there's too many negatives. There we go. And we'd have +2, and these would be our solutions on the number line. All right, that's how we graph solutions on a number line. You'll figure out why that's important as we go through this investigation. Okay, so let's start out by factoring that quadratic. So pick your method. I'm going to mix it up a little bit. I'm going to do a box. Okay, box. So I know I need x and x. That gets me my x squared. and I need to make a negative 12 here. And so I got 1 and 12 and 2 and 6 and 3 and 4. And I know that, let's see, I got to make a negative product. Negative product, so that means I need a plus and a minus. And I need to make a positive 1. And this is the only way I can make a positive 1. So it must be a plus 4 and a minus 3. And so that means the 4 is up here and the minus 3 is down here. So I have x minus 3 times x plus 4 equals 0. And so I solve my factoring equation. I have the scenario just like, I'm zooming out here, but just like I had in C. I've got my two factors. Their product equals this quadratic. And either this one is 0 or that one is 0. So the way we set this up as a process, without thinking too much about it, is we say x minus 3 could be where the 0 is, or x plus 4 could be where the 0 is. And so when we add 3 to both sides, we get a solution of x equals 3. When x is equal to 3, 3 minus 3 is 0. And when we solve this expression, we get x equals negative 4. And when x is negative 4, then that factor is 0. And so I guess looking at the notes, this should be down here, right? We factored right here. We're solving right here. And it just so happens that if we can kind of highlight it this way. If we look at the factored expression here, and let's take an orange here. If we look at that x minus 3, x plus 4, and we call that a function so that we could graph it, this would be intercept form, right? And your a is equal to 1, and so we could, not that we really need that because we would be graphing the intercepts, right? We would say here is one of my intercepts at 3, right? This is my P. And so this is my P, and this is my Q. My Q is negative 4. P equals 3, and my Q equals negative 4, right? So there are your intercepts. And then we could do the to graph this, we could do you know, the symmetrical thing. I'm having a hard time with words, right? Move in and move in, move towards the center, move towards the center. We're moving towards that vertex, right? So that vertex must be at negative 1/2. So, you know, using that, what we notice is that the intercepts, get back to orange, the intercepts are x equals 3, that's my P, right? And x equals negative 4, and that's my Q. And the y coordinates are both 0, right? We have 3 comma, whoops, that's a way too big of a bracket. 3 comma 0 and negative 4 comma 0. Those are quotes. There we go. And so we realize that our intercepts and our solutions are the same things. So our intercepts and solutions mean the same thing. Okay, so our answer to 4b and our answer to 5a, so 5a equals 4b in these notes, right? They mean the same thing. So those are our intercepts. Those are, another word for it would be, those are our roots. Another word would be, those are our zeros. All of those are synonyms, they're interchangeable. And then we can go to getting the vertex, right? We could say, well, hey, I've been down this road before in section 6.2. If x is equal to a half, then a half minus 3 and a half plus 4, when I multiply those together, then I can get my y-coordinate of my intercept. That's minus 2.5. Let's see, that's 5 halves. And this is 9 halves. And this would be I would do this on a calculator and get a decimal. I get negative 40 over 4? 45 over 4. Gosh, I can multiply. There we go. Negative 45 over 4. That's just past 11, right? So it's about right here-ish. I'm not going to get too exact about it, but there's my vertex. And then I can go ahead and graph that. I'm going to scoot that over a little bit. That looks kind of decent. There we go. Then we can graph that quadratic. So the idea is that we went back, this is all section, whoopsies, this is all section 6.2, right? When we were using that intercept form, and that section 6.2, we can explain section 6.2 just by solving a quadratic. So, and this is obviously, solving the quadratic is a much more efficient form of accomplishing that task rather than doing all that graphing. So we're going to really focus on doing that solution algebraically now, just to be a little more efficient about it. So our learning target then, is what we call that, there's two of them. One's called the zero product property. So, you know, we're talking about if A times B equals 0, then either A equals 0 or B equals 0. And then our learning target 2 is solving by factoring. Right, we're going to do some sort of method to factor the quadratic, whether it's a star or, or maybe you're using the area method backwards, or maybe you're using just your factor sheet. You know, all those methods we did in section 3 and 4. And then you're going to set each factor to 0. And then you're going to solve and for answers. And those answers are going to be your intercepts, or some people call them your zeros. Or some people call them your roots. There's lots of names for them. So those are the learning targets. If you want to practice on the check your understanding a little bit, you can. But I think looking at the homework, you probably could crank out the homework without doing the check your understanding.